good afternoon, good evening, wherever you may be watching this from. This is Cornelius Lubinda with another video. Now, in this is question D, the last question of the revision exercise, which was reading, find the equations of the tangent and the normal to this curve at the point where y is equal to 7. Take note. They are saying that for you to find the x-coordinate, you need to use y is equal to 7. So our first step is to differentiate this curve. When we differentiate this curve, we are going to substitute the value of x, not the value of y that has been provided, but the value of x that we'll get by substituting. Then we'll find our gradient. That gradient we find will be for the equation of the tangent. But for the equation of the normal, we are going to do the product of perpendicular lines, m1 times m2 giving you -1. Let's get on with the answering. So we have y is equal to 3 minus 2. To take the x up, it's going to be the power -1. Then you differentiate. dy dx is going to be equal to a positive 2x to the power -2. Derivative of a constant is 0. Okay, so dy dx is going to be equal to a 2 divided by x raised to the power +2. This is your dy dx. And then we are substituting y to be equal to 7. So 7 is going to be equal to 3 minus 2 over x, like that. What do we do here? What we do is that we can take the 2 over x the other side and then the 7 the other side. So these two, they can interchange, and then it will become 2 over x is going to be equal to 3 minus 7. Okay, so 2 over x is going to be equal to 3 minus 7 is a -4. Cross multiply, so a -4x is equal to a +2 divided by -4 divided by -4. X is going to be equal to a -12. Take note. So we can even remove what we have done, but in an exam setting, this is important. So -12, 7 is your coordinate. -12, 7, that is your coordinate. And then to continue, to find the gradient, the first gradient, we substitute x is equal to -12. M is going to be equal to a 2 over, okay, x squared. And then we'll say when x is equal to -12, which is going to be equal to 2 over a -12 squared and 2 over 1 over 4. This is a complex fraction. We just multiply by the reciprocal. So m is going to be equal to 8. And then after finding your m, we are going to use the gradient intercept form like that. So after you have left your equation, the gradient intercept form, we substitute the value of y, the value of x, the value of m to find the value of c. So the value of y is 7 is equal to 8 multiplied by x -12 plus c. 7 is going to be equal to a -4 plus c. 7 plus 4 is going to be equal to c. 11 is equal to c. Okay, so 11 is equal to c. Therefore, your equation of the tangent is going to be y is equal to 8x plus 11. So this is your equation of the tangent. And then to continue, to find the equation of the normal, you know that your m, okay, your m was equal to 8. Now this 8 is going to also become your m1. So m1 times m2 is equal to -1, product of perpendicular lines, okay? The gradient of perpendicular lines will give you -1. So 8 times m2 is equal to -1, m2 is equal to -1 over 8. That's the second gradient. This gradient that we have now found, we're going to use it for the equation of the normal. So we substitute this, the x-coordinate there, -12, to find the value of c in the slope-intercept form, which is y is equal to mx plus c. And then the y-coordinate, you can see that positive 7 is equal to their negative 1/8 multiplied by x negative half plus c. Okay, so we can clean up to create more space. What we are going to do, we multiply the numerators, denominators. 7 is equal to a positive 1 over a 16 plus c. We can express 7 as a product in the form of a fraction. When you do this, you're going to say 6 times 7, 42. Okay, so it's the same as writing 112 over 16. Okay, so 112 over 16 minus 1 over 16 is equal to c. That's the method we are going to use. And then this will just become 111 over 16 is equal to c. Therefore, the equation of the normal is going to be y is equal to negative 1 over x plus 111 over 16. And this would be your final answer. Thank you so much for watching. This has been Cornelius with another video, and bye-bye.